Okay. I hope I am clear. You are able to hear me and uh, see me. So it's a 30-minute session today as well. So Mondays and Thursday it will be 30 minute and um, rest like Saturday it will be 1 hour 30 minutes. So that's 90 minutes. Right. So uh, let me say, let me share my screen and let me know what you see. Okay. So So today we'll discuss about one second. Anish. Okay. Okay. So today we're going to discuss about data warehouse versus database versus data warehouse versus data lake. Since folks had an issue understanding it, I'll just take this session today to deep dive or make it clear in another, try to make it clear in a different way possible. Okay. So before understanding DB, right, let's understand how a application work at a very high level. Okay. So let's say you have a something like an app you have created wherein you have a login, right? What are features you have in a app, right? Let's say it's an order kind of a um, e-commerce app. So you will have a login, right? Login, sign up, correct? Then you will have um, then you will have the items, the inventory status, the product table, right? Products that you are going to uh, showcase to the customers. Then you will have um, inventory. You will track somewhere, right? You will track somewhere, okay, how much is left, how much is not left, right? So it's then you will have product will have like pricing as well. So there will be a pricing table. Okay. So what happens? This app, right, in order to work, it needs backend and needs to interact or save this information somewhere, right? It can be, let's say it's very high level or very starting early stage uh, company. They can use sheets as well to store products data. So how it will be stored? Like product you are selling, like t-shirts. Okay, one item can be t-shirt, then color, size, then fabric, right? So these things can be saved. Okay. Now, where you're saving, here, let's say let's consider this is being saved in some storage. Okay, let's not call it a database. Database is called because you have a collection of data you're collecting over there. So what happens here is, right, it's getting saved here, stored here. So what will happen inside this block? You will have different You will have different tables for, let's say, there will be a login table, or let's say, not, let's not call it authentication, let's call login only. Okay. There will be login or sign up table, meaning if you are trying to sign in, right, you will give your email ID and password, and what it does, it tries to match over here. If it is there, then it will let you log in into the system. If not, it will show error, or it will ask you to sign up. Okay. So what the app is trying to do, it is trying to communicate with it, with the DB, okay, and fetch information in real time. Okay. So to run a application, a DB is very important, right? So uh, consider it like this. If you understand till here, right, why DB is required, right? So here mostly DB is used to read and write and update. Okay. Let's say reading is when you log in, it reads your data and then it lets you log into the system, right? Now, the very first time you wants to sign up, right? That time you are trying to write to the system. Okay, you are what you're writing, that you will have this email ID, let's say some email ID and your password. So you are recognized like that. So you will have some user ID. Okay, your identifier, because system does not know who Akash is or who Priya is or who by name, right? They use some user ID and then you have password and ID, right? So you write it over there. Now next time, let's say you forgot your password, so what do, you update it, right? So that's wherein databases are used. So that is one way of thinking where databases are used. Now, that being said, you can do it's first of all, so how it is, right? It is generally, it is fast. Okay, the attributes of it, structured in nature. Okay. And then handles can handle a lot, handles large number of user. Okay. And that already said, right, read, write and update operations, and delete as well. Delete as well, let's say you want to uh, go out of the system, you don't want to use that app, so you will delete the entire your digital footprint for that app, right? So that's how, when on Saturday when I was saying that this is more used for real time, this is what I meant. So there is one another example. Yes, Samudra, go ahead. Yes, Samudra, you have your hand raised. No, 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 no. Data lake is something. We'll come to data lake. Let's keep our focus in databases as of now. So far, there is uh, um, no issues, right? You still have your hand raised. If you have any questions, please speak out. Okay. Okay. So there is another example, that consider this like, you own a shop. Okay. You own a shop, like take any shop which is like snacks or cake shop, right? So what happens, you have a billing software. Okay. So here you will let's say number one customer comes, right? He takes one red velvet cake, the price and everything is stored here, right? Then you have n number of customers, then same thing will be stored, right? Now if you ask him that how much did I pay, what did I buy, okay, on this day, and all this information is getting recorded in some DB. Okay. Now if you ask him or her that how much did I pay, I came just an hour ago, and how much did I pay, so he'll be able to tell you in that in real time. Okay. So This is more like uh, if you want to use something in real time scenarios, then you use this. Okay, so like stores current data. It is live, and it is structured in nature. Once again, it is structured in nature. Okay, and so he'll be able to tell you but because it's live, so he will be able to tell you that you purchased so and you paid this much, right? But if you tell this person that, what did I buy on last Friday, he won't be able to tell you this. Okay. But here is the catch again. So far, so good, right? I'm going to say something very, very, very contradictory as of now. Many of you who has some experience will say, no, I have queried DB for past data also. This you got right. This is mostly used for live and real-time processing and current data. Okay. That's why inventory and all those stuff are real time, should be updated in real time. Okay. If this is clear, now let me drop that bomb over here. Most of the folks will say that for past date also I have used DB. I have used MySQL. I have used, PG SQL. I have used Oracle. I have used Hive. And this is also right. In a way, this DB, right? DB can is primarily used for, you know, supporting apps. Okay. Okay. But it does not mean that we cannot use it for historical reporting. Okay. So since it's like this, right? The analogy goes like this. Um, in your home, you have a plate. It's not only used for eating. It is used to, you know, uh, chop vegetable. It is used to clean vegetables sometimes. It is also used, sometimes it is used to, prepare the dough when you make a bread, right? So, but its intended use is to have food in it, right? But it can use it. But what happens? So when you use it for historical reporting, right, it will be a bit slow. Okay. Cannot hold large number of users. This means if let's say 1,000 analysts start querying this DB, okay, start querying this DB, it will be very slow in nature. It will be very, very, very slow in nature, right? So that's why, uh, and it will obviously, if let's say if some organizations are using same DB, let's say inside DB different table, then it will slow down the app itself because somebody mentioned crash, right? If the storage is full, let's say that you had 100 GB full, right? 100 GB capacity of this DB, let's say for example, and it's full like our hard disk in laptop. What it does, it slows down our environment. So your app can crash because of this as well. Okay. So here, so far so good. DB uh, primarily uses supporting apps and real-time scenarios where you need to update the inventory, where you need to log in, log outs. Then you have signups, then you have ATM transactions where you need to, let's say in one day you are using your ATM like three times a day. So let's say at 1 a.m., 1 p.m. you used your name, your bank account number, then you have, credit and debit, and then there will be a timestamp. Okay, so it is updated every real time, right? Right. So for all these purposes, you will use DB. Okay. Any questions so far? Let me see the text. Okay. Okay. Now, so you have this app, okay, and it is uses DB, okay, right? Now, what happens is, since it is used in real time scenarios, and it is not preferably used for historical reporting. Historical reporting means, for example, here I'm checking every day, right? Every day, what's my debit and credit? But let's say I want to understand, ask for a statement, your bank account statement, right? Do you get statement every day? You don't get, right? You get at the month of the end of the month, right? Right. So what happens when we understand this, or also, hmm, okay, right. So when you okay. So when you get at the month of the day, right? So that is called as historical reporting. Means you can go back in time and check in retail scenario, for example, the shopkeeper thing, right? The shopkeeper analogy that I gave. For example, Akash today bought 100 rupees sweets. Okay. But if I want to analyze how much Akash has spent over the period of time, and when did he, started shopping from here? So it is going back in time. For all those things, what we do is we go to data warehouse. Okay. Now you will say where this data warehouse will get data. So what happens here in DB? It lives for a day, right? It's very real time, near real time. It lives for a day. Then by strategy, what folks do, like if you are somebody like Target, Walmart company, that kind of company, or DMart, what they do is, since the transaction happening every day is so huge, or Zepto, or any these kind of big giants, what they do is they store it here, but after end of the day, right? They will decide some time, and they will dump the data to data warehouses. Okay. So there is this process called as ETL or ELT. We'll understand this later, but through some strategy, through some pipeline. Remember, I hope this word is not new. Pipeline we have already discussed twice. Okay. We'll discuss again and again, but it shouldn't be like, it's very new to me. So they will have some pipeline. Consider it like a gas pipeline. Okay. Once this is produced on and it lives there for day one, at the end of the business hour, at the end of the day, it is, it travels here to data warehouse. Okay. Now what, at a strategy level, what we do is we, okay, so to shift here, this pipeline has a lot of processes, right? So what it will do, it will take the data, it will structure or transform it. Means, let's say here you have only, in this database you have only uh let's say Akash, customer name, ID number one, okay, item, it took cake, okay, and price 300, quantity is one, okay. So it gives you this much: paid status, paid, okay, and so on and so forth. You can think of like you mode of payment, then you can think of address and etc. Right? So all these leave here. But for analytics, if we want to calculate revenue, right? How much revenue Akash is given. So you need to pass on these data plus add one more column called as revenue, which will be 300 into 1, which is 300 rupees. Okay. Now, this is revenue for that day. Okay. So every day the data is sitting over here. So it will have all the, like, let's say I have come 1,000 times. So I will have 1,000 prints over here, 1,000 rows for me. Then 1,000 times maybe let's say Priya has come. 1,000 times Suraj has come. So 1,000 times other folks have come. So all the data will be stored here, and it is historical. It is not real time. It is not live data. Live data stays here, and then it through pipeline it is brought here. In while in the pipeline it is transformed. Okay, just understand this. Now when it comes to analytical layer, I mean in data warehouse, right? So it is, DB is small, data warehouse is bigger than the DB. Okay, it can hold enormous amount of data. It is not real time, not very query wise it is fast. You can process a lot of data, right? So all these things are there. It can store and compute huge humongous amount of data, and it is the data which stays here is analytics ready, which means you can do all sort of reporting, analysis, and bring out insights on top of it. Okay, so these data will be consumed by analytics layer, I mean analysts. So there can be data analysts, it can be bi engineer, means business intelligence tool, or data scientist also. Okay, but hardly they use it, but let's keep it like data scientists also use it. Okay, understood. Now I'll go and once I'll just clean this up. So far so good, folks. I hope it is clear. Now what happens, you know let's say strategy wise, right? If all the data is transferred here, then what happens if I need raw data, the actual data when it was there, which is not transformed? If I want to look at to that, how it will happen? I will not have any data, right? Because see, here it was real time data. No, it was not analytics ready. But I moved it to directly, I moved raw data and structured it and then formatted it, transformed it, and saved it to DW, I mean data warehouse. But in data saved in DW is not raw data. It's not the way it was captured, right? So what to do in that scenario? Because we always want to have the raw data, because that is the source of truth. That is where we will compare if this is right or not, right? So what people or companies do, they kind of store a copy of these data in data lake directly here. Okay, and raw format. Okay, and the way it was captured, the way it was captured. Okay, right? So what happens, one copy is saved here, raw is saved here, and then it uses over here. So this one is used for, this whole purpose is for analytics. This is to save, and I'll tell you where it is used. But as of now, just think at as a dump yard where the whole raw data is saved. Okay, it can hold anything, anything in nature. It is not supported by for queries. We have to make some adjustment and then query. Okay, so far so good, folks. Let me know if you got this, uh, if you understood this. Any thumbs up? Any okay. What about Samudra? Did you get it? Mohit? Okay, awesome. So that is how we structure our strategy. Okay. So when I say when we were going through this, right? Database, data lake, data warehouse, right? Few examples that I've given, uh, S3, GCS, and Snowflake and Redshift, right? So one of the things that I'll just digress a bit and take you through this Snowflake, right? I mean, I told this about this in last session as well, but let's revise. So Snowflake, BigQuery, Databricks, okay, all these are cloud native, meaning for Oracle, MySQL servers, MySQL, SQL Server, all these you have to download in your system. Okay, download in system, set it up, and then use. Okay, but when it is cloud native, right? What it does is you just go log in or sign up as as the way you sign up for any of the apps, right? And then you just start using it. So there is no overhead of managing it or setting it up. Okay, so that's the difference. Now we'll understand those snowflake here and there, but yeah, that's what these three data storage are important to understand. Now let's move ahead and understand, since when you understood database, data like data warehouses, right, you will be able to understand OLTP, OLAP, etc. Okay, so let me go to my Figma. Okay, now, okay, so we when we saw that this DB is real time, okay, it's focused on real time, right? Let me, okay, right, DB is real time, okay, and um right, then DW is, can perform analytics or historical reporting. HR, historical reporting, this is not the HR that we call about, right? So there is terminologies, so it follows OLTP. Okay, this is the same thing whatever I have told you how this DB functions. The highest, we human beings tend to complicate things, so that's why we have given OLTP name, and this is OLAP. Okay, so hear me out. OLTP is online transaction protocol, processing, sorry, online transaction processing. Okay, which means which means day-to-day operations. Remember, DB, our DB holds the order that, Akash went to the sweet shop and purchased 100 rupees sweet, and then other person and then next person. So it holds day-to-day operations. Okay. It is instant, because if you are trying to log in and it takes a lot of time, so it is not a good experience for the consumer, right? It uses insert, update, delete. So when you first time log in, that is insert, right? Then when you are trying to forget password, it is updating the record over there. When you are exiting out of the system, that is deleting the record, right? So this is OLTP, current data. Okay, it's current data, a small rows, limited fields that we store. These are the example. So this is called as OLTP. It is only used for, day-to-day business. I mean, the only per day business lens. Okay. Now OLAP, which is used by data warehouse, okay, is what, like I said, analysis and reporting. Latency, when remember that example, with 1,000 analysts are querying on to the same, uh, you know, DB, so it will slow down. Okay, for analytics, talking about analytics. Okay, but DW, that data warehouse, will not slow down. Okay, uh, you can perform complex queries. You cannot perform complex query. I mean, you can, but it will have some latency over there. Historical data is there. Here you just store current. In data warehousing, you will go back. You can go back in time and analyze uh, the whole data. Here you cannot do this, right? And some of the examples are Snowflake, BigQuery, Redshift, and Databricks, and these things, right? So this is what OLTP versus OLAP is. Let me check messages. No, okay. So this is very, very important in if you are somewhere into somebody who is going to go for an interview, or you have, any kind of interview. These are the questions now asked to senior level as well, because these are basics. Okay. So yeah, let me know if it is if you were able to understand, because uh, that's important, right? So any thumbs up, any yes or
So I
no?
think for OLAP, which means we can query in data warehouse, and OLTP, we are operating on database.
Right,
Correct me if I'm wrong.
right.
Okay.
Yep.
So obviously, the whatever the criteria falls for database, it will
Oh,
follow OLTP. Whatever criteria falls for OLAP, it will. I mean, data warehouse, it will fall for OLAP.
right. Yeah.
Okay.
That's kind of analogy that contrast that I wanted to bring. Yeah.
Okay.
Okay.
Understood now.
Okay. Others, if you are okay, let me move ahead, or let me stop it here. Okay. Any questions so far? I'm ready to take a question. Like, I mean, it's 30 minutes now. We'll start from ETL and ELT in later, and we'll finish it off in this session in I mean, this data lifecycle in next session, because it's hardly things left. One of the most important thing is ETL versus ELT. That this one, remember I was talking about the process that happens, right? This one, the ETL, the pipeline, the gas pipeline I was talking about, how it happens, the strategies ELT and ETL, right? So we can take it later. But if you have any questions on these two things, OLTP, OLAP, and data warehouse, database and data lake, let's discuss. If not, we are good to close for today, and we'll start from ETL versus ELT next session. Okay, I think we are good. Okay, I have prepared a PDF. I'll share with you all for this data warehouse and database and data lake comparison. Just go through it and look into it. Anybody, if you have any question, I'm asking again. Anybody, just let me know so that we can discuss here. And don't shy away to um, ask questions. Nobody knows anything. That's for sure. Was my video on? Ah,
Yes, yes.
yeah. Thanks. Okay, I think we are good. If not, if you're not able to, I know there will be questions. If not, let me know in the chat. I mean, in the WhatsApp. So that is there, and I have a good amount of curriculum read prepared for Claude. So maybe this Sunday we'll keep a 90-minute session, and that will go for at least 3 Sundays. So we will deep dive into how Cloud works and every aspect of it, and it will be a fun session. It's very nice. Okay. Yeah, then that is it from my side. Still, I'll give 2 minutes for you folks. If you have any question, let's go through it. If not, we can disperse. Guys, it's better to ask questions here rather than on call or on WhatsApp. Can we save it all in database data lake instead? Obviously, we save everything in data. We can save everything in data lake, but what will you do out of that? You cannot do analytics. You cannot do much of the things over there, right? Since if you want to do any historical reporting, you won't be able to do it, right? Uh, and there is app crashing. App will not be able to read only. So, for example, let's say you like we understood, data lake is a dump yard. You without any structure, your app cannot read without any structure. It has to be, there has to be some structure to it. Otherwise, the app will not understand the date the let's say you are hitting login and it goes to a database, it will not be able to read through it and come back again. It will say error because it is not able to read it. So, for example, we are talking in English, right? You are able to understand because you know English. If you do not know English and I do not know your language, there will be no, collaboration or communication. So to speak, right? So that's how it works. The app needs structured to read from. That's why DB is used. We can put it into data lake because we saw that example where database to data lake we were dumping it just to store and to be safer side that in future if I want the raw data, I can use it for any other analytics purpose, right? So that is how it is used. Again, the same plate analogy, right? Comparison. Plate is used to, keep food and eat through it. You can also use it for different purposes, but it doesn't mean that it was intended for that, right? I hope it is clear. Hmm. Okay. Okay, guys. We'll stop the recording and